Hello, my name is Sharon Pruitt. In this analysis, I conducted an ANCOVA to determine whether there were statistically significant differences in test scores among three classes, Smith, Jones, and Brown, while controlling for the covariate periods missed. The research question was, after controlling for periods missed, is there a significant difference in test scores among the three classes? The null hypothesis stated that there is no difference among classes after controlling for periods missed. The alternative hypothesis stated that at least one class differs. Prior to the ANCOVA, the normality assumption was evaluated using histograms and descriptive statistics. In order to gather my data of the normality test, I go to Analyze, Descriptive Statistics down to Explore. I move Test into the Dependent list and Class into the Factors list. I click on Plots. Unclick stem and leaf, click on histogram and normality plots with test, then click continue and OK. The distributions appeared approximately normal with no extreme skewness or kurtosis. Additionally, each group contained 30 students. N was equal to 30 for each class. When we look at each group, the ANCOVA note is robust to minor deviations from normality. And we go to the test of normality, we see that each class, Smith, Jones, and Brown, has a p-value greater than 0.05. Therefore, the normality assumption was considered met. Next, we wanted the homogeneity of regression slopes assumption evaluated. In order to do that, we go to Analyze, General Linear Model, Univariate, and I move class into the fixed factors box. Test is the dependent variable. We move that into the dependent variables box. Click on periods missed and move that into the covariance box. I go to model and change from full factorial to build custom terms. Click on class, move it into build terms, and add it into the models box. Click on periods missed, move that into build terms, and add it into the models box. Then I go back to class, click it, move to build terms, click by. Now click periods missed and move that into build terms. And we have class by periods missed. Move that or add it into the models box. I click continue. Then I want to gather the homogeneity test for that and the effects of estimates of effect size as well as descriptive statistics. Click continue. Okay. And I get my results. This homogeneity of regression slopes assumption was evaluated by examining the interaction between class and periods missed. The interaction was non-significant, indicating that the relationship between the covariate and the dependent variable was similar across groups. Therefore, the assumption was met. We see that F with 2 and 84 degrees of freedom gives us an F value of 0.723. The p-value was 0.488. Since it was greater than 0.05, the assumption was met. Next, we wanted to check the homogeneity of variance for Levene's test of equality of error variances. The way we do that, we go to Analyze, General Linear Model, Univariate, And we note that the dependent variable is already in the correct box. Fixed variable class is in its correct place, as well as our covariate periods missed. But we must go back to model and change that back to full factorial. Click continue, and we want to click on EM means. We'll move class into display means for box. Click on compare main effects, and then click the drop down box of confidence interval adjustment. Click on Bonferroni. Click continue. Then I want to go to options and make sure my descriptive statistics, estimates of effect size, and homogeneity test boxes are clicked. Continue, OK. And we want to look at Levene's test of equality of error variances. Note the F times 2 and 87 degrees of freedom gives us a value of 0.371. The p-value is 0.691, and because the p-value is greater than 0.05, the assumption of equal variances was satisfied. Next, we go to our test of between subjects effects. After adjusting for the periods missed, the ANCOVA revealed a statistically significant effect of class size on test scores. F, we go to the class row, and we know F with 2 and 86 degrees of freedom equals 4.116. We see that there's a p-value of 0.02, and partial eta squared is equal to 0.087. Because the p-value is less than 0.05, the null hypothesis was rejected. Note the null hypothesis stated that there is no difference among classes after controlling for periods missed, but there is a difference. Finally, we'll go to estimated marginal means. I'm sorry, we'll go back to 0.087, our partial eta squared. Value of 0.087 indicates a medium effect size. This means that approximately 8.7% of the variance in test scores is explained by class membership after controlling for periods missed. This suggests the difference is not only statistically significant, but also moderately meaningful in practice. Now we'll go to our estimated marginal means and note the adjusted mean scores for each of our classes. Smith has an 84.10 mean, followed by Brown with 80.47, and Jones is 79.93. So we see that Smith has the highest mean score, followed by Brown, and the last is Jones. Noting our Bonferroni's pairwise comparisons, it shows that Smith scored significantly higher than Jones, p-value 0.029. That shows a significant difference in the test scores between Smith and Jones. Smith and Brown has a p-value of 0.075. There is no significant difference in scores between Smith and Brown. Here again, we have Jones and Smith with a p-value of 0.029. Jones and Brown, there's no significant difference in test scores between those two teachers. Therefore, we see Brown and Smith again with no difference in test scores, and Browns and Jones, no test scores. Therefore, Smith and Brown did not significantly differ, and Jones and Brown didn't significantly differ. Smith is the one that scored significantly higher than Jones. That's where the difference lies. We can say that in summation, an analysis of covariance and ANCOVA was conducted to examine differences in test scores among classes while controlling for periods missed. The assumption of homogeneity of regression slopes was met, and we see that the class by periods missed, the F value, F times 2 and 84 degrees of freedom gives us an F score of 0.723. The p-value for that was 0.488. Levene's test, on the other hand, shows F times 2 and 87 degrees of freedom equals 0.371 with a p-value of 0.691. So Levene's test indicated that the assumption of homogeneity of variance was satisfied, and after adjusting for periods missed, there was a statistically significant effect of class on test scores here. F times 2 and 84 degrees of freedom equals 4.663. P, here we are, there's class, and 4.653, and P with a 0.012 value. Partial eta squared was 0.100. These results indicate a practically meaningful difference in performance among the classes. In conclusion, after controlling for periods missed, there was a statistically significant and moderately meaningful difference in test scores among the classes. Specifically, students in the Smith class performed significantly better than students in the Jones class. This ends my video. Thank you.